So let us consider 4.1 number 15, a wizard. So a wizard creates gold continuously at a rate of 1 ounce per hour. Huh. Okay. That was trash, Joe. All right. That part. Important. Is that adding or subtracting from the amount of gold?
Adding.
Okay. An assistant steals it continuously at the rate of 5% of however much there is per hour. Well, that's problematic. Never going to get very much gold with that kind of thing going on. It's hard to find good help, I tell you what. All right, so that's this part here is a what? Is that adding gold?
No, subtracting.
Subtracting gold? Jerk. I guess I don't know whether the wizard's nice or not. You might have it coming. All right. And then we're going to let W of t be the number of ounces that the wizard has at time t. Find W of t and the limit as t tends to infinity if W of 0 is 1. Okay, well, that last bit got substantially more mathy. All right, so let me think about this. I've got some rates, right? Now, if I'm trying to write an equation for W, do I know an equation for W? Like, do I know things about W? I mean, kinda. What do I actually know stuff about?
W prime.
Yeah, I really only know stuff about W prime. So I'm just going to slap that as dW dt. And now what do I know about the dW dt? What do I know about the rate at which gold is changing, I guess?
An ounce per hour.
Okay. I'm willing to say there's plus 1 ounce per hour. Okay.
And we lose 5% of the quantity of gold per hour.
Oh, well, that's real weird. Because one of these is like a constant amount, right? Like, but then there's like this loss. Okay, so let me see if I can split this loss up. One, it's minus. We all agree that it's minus. Okay, and then Bridget, say that again. What the hell is this thing supposed to be?
We're losing 5% of the quantity of whatever gold is already existing.
That doesn't make any sense. I don't know how much there is. How am I supposed to? What are you telling? What am I supposed to write here? Stopped making any sense. I know it needs to be 5%, right? How do I write down 5%?
0.05.
Okay. So it's 0.05 times some damn thing, right? And then what is it that needs to go in here? You said it was the amount? But I don't know how much there is.
Just use a generic W to represent it.
Oh, yeah. Normally I'd just throw a letter in here, right? Be like, I don't friggin' know, X or whatever. But I already labeled this thing, right? I already had a letter for the amount. It was W. You guys on board with that? That was rad. Okay, now what? If I clean up my equation a little bit, so for one thing, I should probably make sure that ounces per hour makes sense here. So if I look at 5% of however much there is per hour, right? So the 5% is per hour. And then what are the units that W is measured in?
Ounces.
Perfect. And this is just a quick idiot check to make sure that if these units here and these units here don't match, you can't friggin' add them together. Does that make sense? Like, they got to be the same category of thing. And they should match the category of thing on the left. So if my claim is that this is dW dt, what are the units on dW dt?
Ounces per hour.
Yeah, they're ounces and hours. So that means that T is measured in hours because I made it that way. I maybe didn't realize that that was a choice I made, but it was a choice that I made. All right, so I got this. Now, if I clean this up a little bit, I have dW dt is 1 minus 5W over 100. Which I guess I can simplify a little bit to minus W over 20. All right, what do I do with that? These are weird because now I have a differential equation that I have to solve, but it's not one of the ones I've been dealing with lately. It's one of the other ones. Like, this is first order, right? You see any T's in here?
No.
Not really. So I think this thing's probably just separable. You guys see that? I gotta get that right hand side to be a little bit more chill. So I'm gonna just massage this right hand side a little bit into, well, 1 is 20/20ths. And so this whole thing is 20 minus W over 20. So if I rearrange that a little bit, I think I've got 20 over 20 minus W. dW is dt. The little algebra here. Everybody good with that? Okay, now what?
Slap some squiggles on that.
Yeah, toss some squiggles on that stuff. All right, squiggledy squiggledy. Pretty sure that's going to get me to, well, I don't really know what happens on the left-hand side, but the right-hand side is T plus a constant. I'll give you that one away. All right, what do you get on the left? What do you need to do over there?
Pull the 20 out, and then, I don't know, the integral of 1 over something is the natural log of something.
Yeah, that's pretty good. I'd probably do a quick U substitution. U is 20 minus W, then du is minus dW. So I need a minus sign in and out. So I think I'm going to end up with a minus 20 times the log of the absolute value of 20 minus W here. You guys all more or less with me on that? Okay, so then I need to what? What am I trying to solve for here?
You want W as a function of T?
Oh, okay, so I need to get W by itself, right? All right, so I think we're gonna, I don't know, like multiply both sides by minus a 20th. So I'm gonna have log of the absolute value of 20 minus W is, well, I guess minus T over 20 plus a constant. Arbitrary constants being fun like that. You can just throw stuff in there. All right, then what?
Exponentiate.
Nice. Good chorus, guys. E to the stuff here. So that's going to give me the absolute value of 20 minus w is e to the minus t over 20. Oh, I guess I get an arbitrary constant up front now, eh? Right now at the moment is positive, right? Then what do you hit both sides with? How do you undo an absolute value?
Plus minus?
School.
Yeah, good. Plus minus is kind of the inverse function for absolute value. It's not really an inverse function, right? You see that? This is 2 to 1. All right, so I got 20 minus w is a now being possibly negative, raised to the, times e raised to the minus t over 20. Now I need to finagle this a little bit. So I'm going to add w to this side and subtract that thing to the other side. So I'm going to get w is 20 minus, I guess, plus a e to the minus t over 20.
That's not a strictly plus sign, is it?
No, because a could be negative. Yeah, that's really totally fair. I just kind of throw in, nonsense at this. Let's see. So now if I'm okay, I feel like I got my model. I feel real weird about that arbitrary constant now, right? Because I just did something a little strange to it, and that made me kind of concerned.
Well, frankly, it doesn't matter because the problem asks us to evaluate the limit as t goes to infinity, and as t goes to infinity, that thing on the right side is going to go to 0.
Oh, yeah. So it is. Why?
Because
No, not the why there, but why. You know what I mean? Like the broader why, not the specific mathematical why, but the broader like, hey, wait, what? So when I plug this in, right, I'm thinking of w of t, and then I'm thinking, all right, the limit t tending to infinity, which is what the problem asked for, of w of t is 20. What the actual? Like 20? Where the hell did that come from? Like it's 20. Are you freaking kidding me? Like obviously we screwed this up somewhere. Like there's no way, right? Like he's making an ounce an hour and 5% of it's getting stolen all the time. 20? Where the frig is 20?
Eventually, he'll have enough to where he's losing the same amount he's gaining.
Wait, what?
I know this is blowing your mind. It's
No,
incredible.
no, that was really good because it's not actually quite true, but it's definitely the right answer.
Well, like he'll have enough to where 5% of what he has is the same as 1 ounce is what he's getting per hour.
Yeah, that's what I wanted to hear.
Yeah.
Okay, so please note if w of 0 is 1 is actually just a tiny bit important here, right? You want to know that he starts out with less than 20 and not specifically, well, I guess it doesn't really matter. So this one rises to 20. If he started out with more than 20, what would happen?
Would it be exponential decay until we got to 20?
Yeah, it would fall to 20. And if he started out with 20, then the rate of change would be 0. Right? And it would be constantly 20. You guys see that? All right. Questions, thanks.
for these problems, I think the book uses complementary solutions. Would you be able to explain that more, like what they're doing there?
Complementary solutions.
Yeah, they end up with q equals u e to the minus kt, and then they find u prime equals a e to the kt.
Oh, sure. Yeah. So the other option for solving this kind of differential equation, right, is to rearrange it to dw dt minus 1 over 20w. Rewrite that a little bit. Is 1. And then you can treat this as a first order linear non-homogeneous ODE and apply variation of parameters to it.
Gotcha. Okay.
I would tend not to do that, but you certainly can. If you do that, you'll get the same answer out of the end. But yeah, that's what they're doing.
Gotcha. Okay. Cool. Makes sense.
Yeah, they like. I like how hard this book leans into variation of parameters, but every once in a while I'm like, dude, it's separable. Just freaking separate it. In the case that this 1 over here wasn't a constant rate, then we would maybe have some more work ahead of us. Like if it was, he creates an ounce more every hour and starts at 1. Right. Then we would have this like, okay, so the first hour he creates 1 ounce, the second hour he creates 2 ounces, the third hour he creates 3. Then we'd have a T over here. Okay. And then we'd maybe have some separability problems.
Gotcha.
It's a little bit harder to put that kind of stuff in words, which is why you're not seeing it in here.
Okay.
Those things do happen in reality. And the thing that makes reality a little bit harder than the word problems in here, it's like, in a word problem in the book, this little box of words is the universe, right? In a real world engineering problem, you own one of these. You don't know what the hell you have to measure with it, but you own one of these. You also own a tape measure that's 100 feet long, and a laser that goes out to 1,000 meters, and like you own scales, and you have a scientific weights and measures catalog on your desk. Do you have one of these, Bridget?
I don't honestly do a lot of that, but I do have like Perry's chemical engineering handbook.
Yeah, exactly. You have all these horrible books and these catalogs where you can buy machines to measure a variety of things. And like oftentimes you just don't know what it is that you need to measure in order to formulate this little word problem for yourself. And that is honestly one of the things that we don't teach well because it's really, really hard to teach.
Yeah. We gather like a lot of process data. I have a sensor next to my desk. If you guys want to see it.
You have a sensor next to your desk?
Yeah, I have a it's a refractometer. So it measures like inline bricks.
Oh, cool.
You know what bricks are? Like solids.
Yeah, you showed us a picture of cheese bricks. Is that what you're talking
No,
about?
it's different.
Oh.
That's funny. No, bricks are like it's a measure of solids, or you'll use it to measure sugar and wine. So we measure solids in line, so we can see like if you're concentrating something more or less over time.
Gotcha. Yeah, this is one of the challenges about kind of teaching the broad idea of engineering. It's like, I don't know exactly what areas you all are going into, so I don't know exactly what things to lean on. And not having done all of those jobs, I'm also not completely sure what it is that everybody, specialized instruments look like. There are a huge number of really cool instruments to measure really weird stuff.
That's true.
All right, so good enough on the wizard question, at least. This is, by the way, essentially applicable because this is how dosing for medication works. When they're telling you, take this medication twice a day for 4 days, what they're trying to do is they're trying to get to a bloodstream level, and they have some like knowledge or some guesses at least about how the human body works, how much water you take in and put out every day, and that's basically where most drugs end up. It's not entirely true. Some drugs are fat soluble, so weird stuff happens there. See episodes of Doctor House. There are maybe 4 or 5 that have that theme.